Hello and welcome to Kumats Online Academy. Today we have a topic we call basic trigonometry. We are going to study trigonometry, and in trigonometry what we do in it is trying to measure the sides and the angles in a triangle, measuring the angles and the sides and the angles in a triangle. In basic trigonometry, we'll be looking at the right angled triangle. We'll start with right angled triangle. You know that we have different styles of a triangle. Studying the angles and sides in these triangles all fall into trigonometry. But we are starting with the basic one, which is the right angled triangle, which is the most common form of a triangle. So that is why we refer to this one as basic trigonometry. It is from this that we get the foundation that we need to advance or understand the other trigonometries. So we start by looking at Pythagoras theorem. Let's visit what we know about Pythagoras theorem. In Pythagoras theorem, it is talking about right-angled triangle, how to determine the sides of a right-angled triangle. Pythagoras theorem is concerned with the sides of a right-angled triangle. The sides of a right-angled triangle, Pythagoras theorem. Pythagoras theorem. So, a right-angled triangle is an angle in which one of it is a triangle in which one of its angles is 90 degrees. A triangle in which one of its angles is 90 degrees or is said to be perpendicular. At a point in the right angle triangle, the two sides are perpendicular to each other. And if two sides are perpendicular to each other, the angle they will make is called angle 90 degrees. So, in drawing a right angle triangle, we can have something like this. We use this box or symbol to show that a side is perpendicular. Okay, this shows that the angle there is angle 90 degrees and that the two sides that form the angle that they are perpendicular. This is a sign of perpendicular. Perpendicular. Perpendicular as an angle 90 degrees. When we have a right angled triangle, this is a right angled triangle. In a right angled triangle in which one of the angles is 90 degrees, like this one we have here, the side that is facing the perpendicular side, the perpendicular sign or the angle 90 degrees is called the hypotenuse. Hypotenuse. So this place is called the hypotenuse. 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 The sides, the other sides of it are called adjacents. So this place is called an adjacent and this place is also called an adjacent. and adjacent. If one of the angles, the other angles, is given again, then the side that is facing that angle is called opposite. For instance, if we have this right angle, this angle 90 degrees, this one is apart, this one is standard. Now we have two other angles here. Assuming that one of these angles is given, maybe this one, theta. Now the side that is facing this angle is called opposite. That means that if one of the angles, the other angles, is given, then the adjacent side that is facing it will become an opposite. You know that without the angle here, without this angle, we call this side adjacent and we also call this side adjacent. But when an angle is given this place, the side that is facing this angle is now called opposite. Opposite. So this place become opposite O. So in a right angled triangle, if the angle 90 degrees is there and then the other angle is given, then we have three sides there, and the three sides are the hypotenuse, the adjacent, and the opposites. So this is what we have in Pythagoras theorem, and this Pythagoras theorem, this theorem states that in a right-angled triangle like this one, that this side, which is the opposite, this side, which is the hypotenuse, that the square of it is equal to the square of the adjacent plus the square of the opposite. That is, the square of the hypotenuse is equal to the square of some of the other sides, either the two adjacent if the other angle is not given, or the adjacent and the opposite if we know one of the angles. So it is actually saying that if we represent the hypotenuse with h squared is equal to the adjacent square. Let's represent the adjacent with a squared plus the opposite squared. This is what we have in the Pythagoras theorem, that the hypotenuse squared is equal to the adjacent squared plus the opposite squared, or is equal to the sum of the two adjacent squared. Pythagoras theorem. For example, let's look at one example. Example 1. If we have a triangle like this, if we are given this triangle, this is perpendicular, and being perpendicular, we already know that it is 90 degrees, and we have this place as h, and we have this place as 2, and we have this place as 3, and we are asked to find the value of h. What is this value for h? Using Pythagoras theorem, this place is the hypotenuse because it is facing the angle 90 degrees. So we now say that h squared is equal to 2 squared plus 3 squared, and h squared is equal to 4 plus 9, which is equal to 13. And this means that h alone is equal to root 13. This is the answer. So h is root 14. Root 13. H is root 13. Now, that is what we have in Pythagoras Pythagoras theorem. That is how to calculate the sides in Pythagoras theorem. I've said that in Pythagoras theorem, we are concerned with the sides of the triangles. The sides of the triangle in a right angle triangle. Now let's look deeper. Now let's create a relationship between the sides in a right angle triangle and the angle inside it. If an angle is given where we have opposite, adjacent, and hypotenuse, now there is a relationship between the sides and the angle. We can use the sides given to us to calculate the angle, and we can use the angle to calculate the side. Now the relationship are this. We have three basic relationships there. Number one, if you have this right angle triangle, and let me say that this place is our theta, this place is now the opposite, hypotenuse, and adjacent, Now the relationship is this. We have that this angle, there is what we call sine theta is equal to opposite over hypotenuse. When we create a relationship, when we divide the opposite with the hypotenuse, it leads to what we call sine theta. When we divide the opposites with the hypotenuse, it leads to what we call sine theta. And when we divide the adjacent with the hypotenuse, it leads to what we call cosine theta. That means we are now creating a relationship between the sides of the right angle triangle and the angle inside it. We can divide this opposite with this hypotenuse. If we do that, it gives us what we call sine theta. This angle, sine of it. Now we can divide the adjacent with hypotenuse to give us what we now call cosine theta. And again, we can divide the opposite with adjacent to give what we call tangent theta. So no matter the side of the right angled triangle that is given to us, we can calculate the angle or the other side that is not given. Sometimes they will just give us one of the sides. Remember, in Pythagoras theorem, we are given two sides and we are to calculate the third side. We have two sides here, but we don't know the third side. If you have only one side known, we cannot calculate the third side. You cannot calculate this side and this side when we don't know the second one. So in Pythagoras theory, we must know at least two of the sides of the right angle triangle in order to calculate the remaining one. We cannot do anything if you have only one of the sides. But using now these rules, we can calculate the other side of the right angle triangle if we know just one of its sides. If we know only the hypotenuse and we know the angle, we can calculate the second side. If we know the opposite and we know the angle, we can calculate any of the other side that we want to look for. And if we know two sides, we can determine the angle inside the right angled triangle. So that is how these laws or these rules help us. This sine rule, we call this sine rule, cosine rule, and tangent rule. Sine rule, cosine rule, and tangent rule. They help us to determine the sides of a right angle triangle when we have only one side of it, or to determine the angle in a right angled triangle. Now let's look at some example. Okay, we say that tangents, when we divide opposite with adjacent, it gives us what we call tangent theta. Now sine theta is also called in short or written in short as sine theta, removing a. Cosine theta is also written in short form as cos theta, and tangent theta is written in short form as tan theta, Now let's look at some examples. Example 2 or example 1 for this. If we have this right angled triangle, we know this place as 2 and we have this place as 30 degree, and we are asked to find this place x. How do we do this? Now this sine theta, cosine theta, and tangent theta, we can combine this relationship in them or create a short, you can create a mnemonics for remembering sine, cosine, and tangent rule. This mnemonics is what we call SOHCAHTOA, or short form, we call it SOHCAHTOA. To remember this, opposite of a hypotenuse, so this gives us, and this adjacent is ka. That is, we take the first one here, adjacent, and then we write the second one, hypotenuse. This one, we take the first one, and then we write the second one. It becomes so, S-O-H, and this one, ka, C-A-H, and for this one, it becomes toa, which is, we take the first one, T, we have T-O, then A. So everything will now give us SOHCAHTOA. This is a short form of remembering the sine rule, the cosine rule, and the tangent rule. SOHCAHTOA, or this basic trigonometries. SOHCAHTOA. S, where S is for sine, O for opposite, and H for hypotenuse, C for cosine, A for adjacent, and H for hypotenuse, T for tangent, O for opposite, and A for adjacent. So we can now use this to quickly remember what to do when we are calculating. Now here we are given the side that is facing the angle is called the opposite. So this x is opposite, and this side that is facing angle 90 degrees is the hypotenuse. We are not giving anything at the hypotenuse. We have the opposite, and the other side is the adjacent, which is 2. So we have opposite and adjacent. Which of the SOHCAHTOA short form has opposites and adjacent? It is this one that has opposite and adjacent. So we are using the tangents. So we now see that tan theta is equal to opposite of adjacent, which means that tan, the angle given to us, theta is 30, is equal to, opposite is x, adjacent is 2. Now this gives us that we can take the 2 to this side. It becomes 2 tan theta. 2 times tan theta is equal to x. That means that x is equal to 2 times tan 30, 2 times tan 30, which is equal to, x is equal to 2 times, if you use your calculator and press tan theta, scientific calculator, they all have tan. If you press it, you are going to get 0.57774. You must always approximate to 4 decimal places. You can use your 4-figure table to get this, or you can just press with your calculator and approximate it to 4 decimal places. So we have 4, not 4 decimal places. You can leave this one. 2 to 0.5774. We approximate to 4 decimal places. Now, when we times these two things, it is going to give us that x is therefore equal to 1.155. This is the answer. That is the side opposite. The opposite is equal to 1.155. So that is how to solve this one. Example 2. Example 2. If we have this triangle, if we have example 2, if we have this, remember that this angle they can start to put here, they can start to put anywhere. This one can face this side, it can be something like this. It doesn't matter. Once we have this perpendicular sign, we know that it is right angle triangle. It mustn't face this side. It can even face upward like this. Once we have that this place is perpendicular, we know that it is a right angle triangle. So no matter the side it is facing, what we look for is the sign for 90 degrees. They can put this perpendicular sign or they can write it 90 degrees. Sometimes they can remove this and just write 90 degrees, or without even putting symbol for angle, they can just put 90 degrees here. So we know that this is perpendicular, or we are talking about right angled triangle. No matter the side that it is facing or how the shape looks, what we have to look for is whether there is angle 90 degrees inside it or a perpendicular sign. That makes it a right angle triangle. Okay, so if we have something like this, and then we have here as 2, and we have here as x, and we have here as 30. Now, can we calculate x? Now here, we have the angle 30, and we have opposites and hypotenuse. The one that has opposites and hypotenuse, we just quickly write our to remember. Which one involves opposite and hypotenuse? That is sine, this one. So we now say that sine 30 is equal to, opposite is 2 and hypotenuse is what we are looking for, that is x. So we now have that sine 30, if we press it with our calculator, we are going to get 0.5000 to 4 decimal places is equal to 2 over 3, 2 over x. We are going to get 2 over x, 2 over x. Now this means that x times 0.0500 0.5000 is equal to 2. For x to stand alone, we divide 2 by this. So we have x equal to 2 divided by 0.500, and this gives us 4. So the hypotenuse here is 4, using this sign to get it. Hypotenuse is 4. Now that we know 2, we know this side, the opposite, and we know the hypotenuse, they can give us this place as A and ask us to find the remaining side. When we now know the two sides and we want to get the third side, what do? We use the Pythagoras theorem to get the remaining sides. We can only apply Pythagoras theorem when we know the two sides of the right angle triangle. So once we have used the sine, cosine, or tangent to get the second side of the right angle triangle, we can now apply Pythagoras theorem to get the third triangle, the third side of the triangle. So assuming we are asked to do this, that is how to do it. Just use Pythagoras theorem and get it. Or let's just do it. Now let's call this place B. Now since we have gotten this side as B, as 2, and the other side as 4, which is the hypotenuse, now let's calculate our B. If we want to look for B, the hypotenuse squared, according to Pythagoras theorem, is equal to opposite squared plus adjacent squared. Hypotenuse that we have here is 4 squared is equal to, opposite is 2 squared plus adjacent is what we are looking for, B squared. And that means that B squared is equal to 4 squared minus 2 squared, which gives us 4 squared is 16 minus 2 squared is 4, which is 16 minus 4 is 12. And that means that our B is equal to root 12. Our B is equal to root 12. So this is how to get the third side of it, where we already know the two sides. Now let's look at another example. Let's try to calculate the angle using the sides. Example 3. Example 3. Now assuming we have this one, we have this place as 3 and we have this place as 2, and we have this angle theta. Now we don't know this angle, which we now call theta. We use theta to represent angles unknown angle. So what we do now is that we look for the sides that are given. The sides that are given are, this side is the hypotenuse and nothing is given there, so we are not checking it. The ones that are given are this one and this one. This one is opposite because it is facing the angle, and the other one is adjacent. So if we have opposite and we have adjacent, we still write our SUCATUA. Which one has opposite and adjacent? That is tan. So we still write that tan theta is equal to, opposite is 2 and adjacent is 3. Our opposite is 2 and our adjacent is 3. So we have that tan theta is equal to, if you divide 2 by 3, we are going to get 0.6667. Tan theta is equal to 0.6667, but we are not looking for tan theta, we are looking for theta alone. For us to get the theta alone, we say arctan this value that we've gotten here. So that will give us, to write arctan, that is inverse of the tan, inverse of this, which is, we write it as tan, we write minus 1 of it, and then the value 0.6667. Every scientific calculator also has arctan this. It is always the second function that is placed on tan. So you see a tan with minus 1 on top of it. You press it and press this value 0.6667, or you can use your 4-figure table to also get it. If you press arctan 0.6667, we are going to get that our theta is equal to 33.7 in degree. So this is the answer. So we've gotten our angle here as 33.7 degrees. So this is how, or what we do in basic trigonometry. That is how to calculate the sides and the sides and the angles in a right angled triangle. In our next lesson, we are going to be looking at special trigonometry. Special trigonometry, that is the trigonometric ratios. We are going to get the values of special angles like sine 30, sine 60, sine 45, tan 45, 90. These 4 angles, they are special. There are some special angles that we call special angles. We are going to look for the sine, cosine, and tangent of them and try to drive them to show how they are gotten, so that anytime you want to solve any calculation and we see something like sine 30, we don't need to check 4-figure table or to use our calculator. We already know that this sine 30 is this. We are going to drive them, show you how to get them. That is what we are going to do in the next class, and I hope that this one is very clear. Thank you.